What's up, everybody? Welcome back to another live stream from Scalar Learning, and I am going through practice test 2 today. Sorry, not practice test 2, practice test 7, excuse me, the practice test 7 no calculator section, and we are going to be starting it right now. So let me jump over here. So we are in day 3 of 5. You got people prepping for the SAT that is coming up this Saturday. So again, if you're new to the live stream series today, what's going down is I'm going to be going over practice tests these next few days. Going to knock out 6 through 8. We've already done 6. Now we're starting 7. And on Friday, I'm also going to give you guys some tips, some last minute tips, things to keep in mind that you want to make sure you have down before you go in and you take the math portion of the SAT. Also some general test taking tips in terms of what's going to go down Saturday, what that morning should look like, what you should be eating, what you should be thinking, what time you should arrive, all that good stuff. Last but not least, I'm taking the SAT. I know I mentioned this yesterday and the day before, but I'm actually taking an official SAT on Saturday, which I'm really excited about. And that means I get to go and sit down, go through a real life actual SAT, and then come back with that intel. Advise you guys, those of you who aren't taking it on this Saturday, I'll talk to you about what I see. Of course, not specific questions, but I'll talk to you in general about how these questions relate to the actual practice problems that we're doing. Any new strategies or ideas that come to mind, I will share them on Saturday, sort of do like a debrief. And then, of course, I'm going to make a vlog video about my entire testing experience, including, of course, the eventual score reveal. So if you want to see for the first time I took it and recorded video, that was in 2016. That is on my channel. You can definitely search for it. Search for SAT score reveal. All right, without further ado, guys, we're going to jump into the video. Now, if you like what you see, please make sure to click the like button. It really helps out. I really appreciate it. You can also leave a comment in the comment section below if you have questions. And last but not least, if you want to see more, definitely click that subscribe button. Like I said, you'll get notifications for the next 2 live streams on Thursday and Friday. All right, let's move on. I got to skip through these verbal sections, so I'm just basically zeroing out on the verbals. Here we go, and continue, finish. All right, and now we go to the no calculator section. So, quick recap. We've got no calculator, which is 20 questions and 25 minutes total. So you have a little over a minute per question, and let's do it. Here we go. And it's nice and zoomed in. Let me make sure. We got we have to leave it at 125. So again, guys, let me know if this is too small to read, but I got some feedback. I've zoomed in. I think it's a lot better now, but I want to hear from you if that's not the case. All right, let's do it. All right, x plus y equals 75. The equation above relates to the number of x minutes Maria spends running each day and the number of minutes y she spends biking each day. In the equation, what does 75 represent? So this is the total. 75 is going to be the total minutes that she does exercise, essentially, right? Because this is running and this is biking. So it's the total of running and biking. Yes. Right? Because that's minutes, running, biking, add them up, that's 75. Next, which of the following is equivalent to this? Okay, so we got to simplify here, right? We got 3x plus 5 minus 6. And again, you can see I'm doing this in the time settings, which is why we're going at this speed. So we do 3 times x is 3x, plus 3 times 5 is 15, minus 6. These guys are like terms. 15 minus 6 is 9. And then we go 3x plus 9. Next, we've got a system of equations. What satisfies a system of equations? So we can use one of two strategies, substitution or elimination. And I like substitution because I already see that in this top equation, x is isolated. So if x is isolated, I can plug in this value here for x. So I can replace x with y minus 3 over 2 plus 2y equals 6. I'm going to multiply everything by 2, and I get y minus 3. This becomes 4y, right? 2 times this just cancels out the 2's. 4y equals 12. Now let's combine like terms. Y and 4y is 5y minus 3 equals 12. Add 3, and we got 5y equals 15, and of course y equals 3. So that's the y value is 3, so it's either going to be, it's got to be b actually, but let's just make sure I'll plug in. If I plug in 3 for y here, 3 minus 3 is 0 for x, and that's what we're seeing right there. Which of the following is complex numbers is equal to, okay, look, check it out. Remember, when we have complex numbers like this, ignore where they give you the definition of I for these types of questions. Just treat it like a variable. The only caveat, we got to distribute that negative here and here. So it becomes negative 9i squared, and then negative times a negative is plus 6i. Actually, no, we do need to recognize this because of the squared value. So if the square root of negative 1 is, square root of negative 1 is I, when you square that, you get negative 1. So we get 5 plus 12i. I'm going to move this over here so it's closer to, the like terms are close to each other. And then that's minus 9 times I squared is negative 1. These two make 18i. This makes negative times negative 1 makes a positive 9. So 9 plus 5 is 14. And then we have it 14 plus 18i. All right, next we have this. What is f of negative 1? Basically, what they're doing is we're plugging negative 1 in for x. So let's go ahead and do that. I'm just going to straight away replace all the x's with negative 1 minus 6 times negative 1 plus 3 over negative 1 minus 1. Negative 1 squared is 1. Minus 6 times negative 1 is plus 6 plus 3 over negative 2. And this becomes 1 plus 6 is 7 plus 3 is 10 over negative 2, which is negative 5. Next, a company that makes wildlife video purchases camera equipment for this. The equipment depreciates at a constant rate of 12 years, after which is considered to have no monetary value. How much is the camera equipment worth 4 years after its purchase? So it's at a constant rate. They didn't actually explain, like it could be a constant percentage, but we're to assume, I think, that it decreases by a set amount, like a linear function, a linear equation. So a set amount over 12 years. So what we can do is we can basically just divide 32,400 by 12, right? So every year it's going to decrease by whatever this value is. So that's 2. Let's quickly do it. 32 minus 24 is 8. 84, that's 7 times 12. See why mental math is important here? And then we're just going to be 0, 0. So it's 2,700. So it decreases by 2,700 after 1 year. 2 years is 5,400. 3 years is 8,100, and 4 years should be 10,800. All I'm doing is I'm adding 2,700 each time. So it should have decreased. It's not how much it's worth. This is how much it's decreased by. So in that amount of time. So then we say 32,400 minus 10,800, which is, 1, 14, 6, 1, 2. So it should be worth 21,600. Now, if I would have tried to go too fast, I could have easily made the mistake and said, oh, it's worth 10,800. That's the value I got. But remember, we got to really try and keep in mind what we're trying to answer in these questions to get that correct. Next, we've got this, which the following is equivalent. Now this is really tricky, right? What's happening here, they haven't just factored it, they've put it into what's called vertex form, or really they've completed the square. So this, you do need to know how to complete the square on occasion. So how do we do that? We say x squared plus 6, or what you could do is you could FOIL all of these and then see which one equals this top equation. That takes a lot longer. Instead, I'm going to complete the square by saying half of this b value squared, which is 9, plus 4, and since I'm adding a random 9, I have to subtract a random 9 to keep things balanced. Then this is what I can now FOIL. So this becomes x plus 3 times x plus 3, a nice perfect square. 4 minus 9 is minus 5, and this is just can be written as x plus 3 squared minus 5, which is this one, x plus 3 squared minus 5. Next. Ken is working this summer as part of a crew on a farm. He earned $8 per hour for the first 10 hours, and then because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves 90% of his earnings from each week. Okay. What is the least number of hours he must work the rest of the week to save at least $270? Okay. So he needs to save $270. So this first 10 hours, he makes $80. Okay. And he's going to save 90% of that. 90% is like 0.9, or we can think about, it's almost like 9 times 8, but 0.9 times 80, hopefully you can do that mentally, and it's 72. So he saved 72 from the first week. Now he needs to save another 198 in this remaining time, right? So it's 198. So he needs to save at least So that's 10x the rest of the week. So we need to solve for x. But remember, it's not just 10x. We're saving only 90% of that 10x. So this is my $10 an hour, and this x is now the rest of the week. Let's get rid of this to not confuse. And then 90% of that has to be greater than or equal to 108. So first, let's isolate by dividing by 0.9. See if I can do it mentally. It is 20. No, it's 200. Sorry, 22. So 220. I think I have to do it to be safe. 0.9, move the decimal over 0, 2, 18, 1, 2, 18. Yeah, it's right. And then 220. So this is 10x is greater than or equal to 220. Then we divide both sides by 10. X is greater than or equal to 22. So you got to work at least 22 hours. What is the least number of hours he must work the rest of the week? I'm just making sure it's not 22 plus that original 10, which would be 32. But 32 is not even an option. So I think 22 is good. Next, Marisa needs to hire at least 10 staff members for an upcoming project. The staff members will be made up of junior directors who will be paid $640. So this is junior directors. And senior directors who will be paid $880 per week. Her budget for paying the staff members is no more than $9,700 per week. 640. She must hire at least 3 junior directors and at least 1 senior director. Okay. Which of the following systems describe the conditions if X is the number of junior, so here's junior, and Y is the number of senior directors? Okay, so I have my first inequality. This is 640X plus 880Y, meaning the cost of the junior directors and the senior directors has to be no more, meaning less than or equal to 9,700. Now this is going to be a system of inequalities, but at a minimum, I can eliminate the ones that have this one wrong. So A, B, C, D. So let's do that. This is wrong because it should be less than or equal to. So A is out. That's correct. This is wrong because the inequality is wrong. So right off the bat, I've maximized my odds to 50% instead of a quarter if we were just guessing. So now we say she must hire at least 3 junior directors. So X has to be greater than or equal to 3. Well, A is already out. And then 1 senior director. So X is greater than or equal to 3. Y is greater than or equal to 1. X is greater than or equal to 3. Y is greater than or equal to 1. And then where's that 10 come from? Oh, hire at least 10 staff members. So X plus Y has to be greater than or equal to 10. B looks like the answer, but let's see what's wrong with D. Yeah, these aren't less than or equal to 3. These should be greater than or equal to 3. So D is out. And there we go. Those are a little tougher, right? Because it's a lot of information that has to be parsed here. In the equation above, A, B, C, and D are constants. If the equation has roots, blah, 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 which of the following is a factor? Okay, so if it has roots, my factors are X minus these values, which means it's X plus 1, X plus 3, and X minus 5. So these would be factors. X plus 1 right there. I'm just checking to make sure we don't have any other right answers. Then I would know I did something wrong. But I don't see anything. X minus 3, X plus 5, no good. So we're golden there. Expression X is... Okay, is equivalent to which of the following? All right, what I'm seeing here is I'm seeing exponents up here and I'm seeing roots over here. I'm also seeing no negative exponents. So that means we need to convert these negatives to positives, combine, and we don't want these fractional exponents. So right off the bat, let me kind of transpose this over here. 1/3 power y to the negative 1. So first of all, this can be, no, you know what? Let's first combine these. So if I bring the x down here, I'm going to add the exponents, right? Not add. So I'm actually subtracting the exponents, but it's going to be -2 minus 1/3, which is -2 and 1/3. 2 and 1/3 negative, which is the same as 6, 7, -7/3. But if it's x to the negative 7/3, I could just write it as x to the 7/3 positive in the denominator. Now what about this? This would be 1/2 minus 1, which would be 1.5 or 3/2. But that's a positive 3/2, so that would be on top. So check this out. Right off the bat, we got this much simpler. Now I'm going to convert these to the roots and exponents, not fractional exponents. So this is the square root of y cubed. And then on the bottom, this is the cube root. That's the denominator, is the cube root of x to the 7th. And that should be it. And let's see if we see it anywhere. Okay, now what they've done, the reason why we don't see it is because they've simplified this. So we can take the square root of y cubed. Y cubed is actually y squared times y. So we can actually take the square root of y squared, which is just y, and then it's left with y inside the square root. What about this? What's the cube root? I can take out actually 2 cube roots, okay? Because this is really like x to the 6th times x to the 1st. The cube root of x to the 6th is actually x squared, right? Because that means that x squared cubed is x to the 6th, which it is. And then what do we have left in here is the cube root of just x. So now we have y square root y. This one, y square root y, x squared cube root of x. Next. The function f is defined as this. The graph of f in the xy plane is a parabola which the following intervals contains the x coordinate of the vertex of the graph. Okay. All right, I have to FOIL, I believe, here. So we get x squared. I'm going to put it in vertex form. X squared plus x plus 3x, which is 4x plus 3. I'm running a little low on time, 12 minutes, so I'm going to have to hustle a little bit faster. Now I'm going to put it in vertex form by completing the square. Take half of this and square it, which is 4. And then we have to subtract 4 to balance it out. So then we can factor this part, and this becomes x plus 2 squared. And that's minus 1 f of x equals this. So the x value for the vertex, here's my vertex is actually, because it's x minus, it should be x minus the vertex. So it's actually negative 2, comma, negative 1. That's my vertex. And this contains it. Yeah, that should be right. So I rushed a little bit there. Let's just roll with it, and I think that was done correctly. As always, we're going to check back at the end, see if I made any mistakes. Okay, we need an equivalent. All right, these are always tricky. And these are particularly tricky for me, and a lot of times I have to work backwards to solve them. And let me think about this. 5 and 1. Is it factorable? X squared. So let me think about this for a second. I don't think it's factorable. So what we're going to do is I could complete the square as half as 1. X plus 1. No, that doesn't help. Oh, you know what? Maybe it does help. I feel like it's one of these two. And I'm going to show you why. X squared. Ooh. Hold on. X minus 3. So we have x squared. And then those ones are left up there. How do we get x minus 3 out of that? And then they get... See, I'm never totally sure about the protocol for this. So what I'm going to do is I'm going to just try and kind of work backwards. So if I have... This one would be x plus 1 over x minus 3 over x minus 3. I'm kind of trying to put everything over one denominator. Minus 2 over x minus 3. Become x squared minus 3x plus 1 minus 2x. Which I think is what we had up top. Okay, good. This is looking good. Minus 3 minus 2. I think I just did it on the first try. This ends up being x squared minus 2x minus 5 over x minus 3. What did I do? I did x plus 1. It's this one. That was total blind luck. And if I didn't get it, I would have tried the next one and kind of whittled it down from there. I'm going to have to come back and check this. So let's remember question 13 because we'll double check at the end. A shipping service restricts the dimensions of boxes it can ship for a certain type of service. The restriction states that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box, which is the same as the top, and the height of the box, sum of the perimeter of the base of the box and the height. So if this is x and then the perimeter of the base, those two have to be less than 130. Okay. The perimeter of the base is determined using the width and length of a box. If a box has a height of 60 and its length is 2.5 times the width, hold on. The restriction states that the box is shaped like the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. If a box has a height of 60 and its length is 2.5 times its width, which inequality? Oh, I see. 60 and then plus x plus 2.5x, and this doubled. This all has to be less than 130. There we go. So now I'm going to say 60. I'm going to distribute this. So I kind of set it up. This is my perimeter, right? 2 times all this. And this is the height. So that's 2x plus 5x. So it's like 60 plus 7x is less than or equal to 130. Subtract 60, subtract 60. 7x is less than or equal to 70. X is less than or equal to 10. So it's got to be, x has got to be less than or equal to 10. I think it's this. They're all greater than 0 because it can't be no size. Right? I think that's right. Okay, let's keep going. Now remember, after 15 it gets easier. Question 16, it resets. The expression can be rewritten as this, where k is positive. What is the value of k? All right, let's see here. K has got to be 1/3 times. So first I'm going to factor out 1/3 out of this whole thing like they've done here. So factor that out. That's x squared. But what does this become? 1/3 of what equals 2? And that would be 6. So hopefully you see how I did that. What I did is I'm factoring 1/3 out of the entire thing because that's what they did here. So if I factor a 1/3 out, it's kind of like I'm dividing this value by 1/3, and that's fine. I get x squared. And I'm dividing 2 by 1/3, and I get 6. Okay. And then now what did they do is they factored this as a difference of squares. So it's kind of like it would become plus, or well, minus plus is the same thing. Minus plus. And then here, this is how we factor a difference of squares. It's like the square root of this minus the square root of this times the square root of this plus the square root of this. So square root of 6 is what we're looking for, and there it is. Okay, now we're on to 16, so the difficulty resets. So let's see. Oh, we're running really low on time. That's bad. Okay, so 2x plus 8 equals 4. So it's 8. So why? Because I divide it by 2, divide this by 2, and I get x plus 4, which is got to be that divided by 2, which is 8. Next, the figure above MQ and NR intersect at point blah, blah, blah. NP equals PR. Let me take a picture. Normally, I like to have like about 7 or 8 minutes at this time. So we're cutting it close. Let's see. And then we've got NP equals QP. MP equals PR. MP. So that equals. Oh, MP, excuse me. MP equals PR. What is the measures in degrees of QMR? So we need this angle. So I'm just going to start filling in stuff that I know. 60, this is also 60. Right? And then, oops, let's just make it 60. And then 70, 60, 130, this has got to be 50. Okay? And these are isosceles triangles, which means, oh, wait a minute. How can that be 50? Oh, sorry. I marked this wrong. MP equals QP. MP equals PR. There we go. This is an isosceles triangle, which means it equals this angle too. 60, 60, these are vertical angles. These are supplementary, so this is 60, this is 120. And if these two are equal, right, they both have to be the same. They both have to be 30 degrees because that's the only way we have 30, 30, 120, add up to 180. So PMR, or QMR, excuse me, is 30 degrees. Okay. The number of radians in a 720 degree angle can be written as a pi, where it's, okay, here's how we convert 720 degrees to radians. We multiply by pi over 180. 720 divided by 180 is 4, so it's 4 pi. And the a value is that constant, which is 4. 3 minutes left. Graph XY plane passes through point 1, 4. You don't have to draw this, but I'm going to quickly do it. Passes through, let's say this is 1, 4. And cross the x-axis at point 2, 0. So it would be like something like this. Ooh, all right. The line crosses the y-axis at point 0b. I actually found it by graphing. It's right here. It's 8. Normally I would actually come up with the equation, but my graph is actually halfway decent. So I can see because of these like if I could draw a straight line, it'd be really perfect. But look at the slope, right? It's going to the left 1. It's going up 4 to the left 1, up 4 to the left 1. So I feel pretty confident. I would actually check algebraically, but I don't have a lot of time, so we're going to keep going. All right, this plus this. The expression above can be written in this form, ay squared, where a and b are constant. What's the value of a plus b? Okay, we need to get in that form. So first I'm going to distribute the 10. So those first set of parentheses are doing nothing. So I'm going to get rid of them. And then I'm going to distribute the 10. That becomes 100y squared. And then 10 times 110 is minus 1100. Okay, here are my like terms here. So we've got, and then also these guys are like terms, right? So we got 100, that becomes 200 y squared. 7532 minus 1100 is 6432, mental math. And then it says, what is it? So my a is right here and my b is right here. So it says, what is the value of a plus b? So it's 200 plus that, which is 6632. You see how careful you have to be with your numbers in this to make sure you don't make any mistakes. I could be off by 1 or 2. Don't really have time to check these super specifically, so we're just hoping that my accuracy is good when I've calculated these. Let's go back to that last question that I was a little iffy on. And let's quickly double check. Okay, this one got 38 seconds. So we chose D. Let me try it one more time. So I said x plus 1. And then what I did was I want it to be over x minus 3. So I multiplied the top and bottom by x minus 3. And then I recombine it with this. So this becomes on top x squared minus 3x plus x minus 3. That's x squared minus 2x minus 3 minus 2 over x minus 3. Yeah, I think it's right. And then this combines to become x squared minus 2x minus 5 over x minus 3. And that was the original. Yeah, I think it's good. And we're out of time. So that's all I had time to check. All right, that was hardcore. So look, at the end of the day, we do what we can, and we just try and be super accurate. Where does the accuracy come from? Well, we're going to check right now to see how accurate I was. But hopefully it's pretty accurate or relatively accurate, and that's just from a lot of practice and a lot of routine. I don't have to think too hard when I'm doing these mental calculations. And which I forgot to mention, of course, when I'm doing these tests, I'm doing them, ideally it's fresh. Like I'm not prepping ahead of time. I have taken this test before, but it's been quite some time. I think it's been almost 6 months or a year or something like that. So it was pretty fresh for me. There was nothing that I remembered. And that's the whole fun of it. Okay. Boom. Got them all right. All right. Sweet. That's awesome. The only thing I want to see is the question number. I want to see how they proposed to solve that question, because that one honestly was pretty, it was fast. It took way quick. It was way quicker than what I thought, but let's see. X minus 3. So the given expression is equivalent since the yeah, but see, you know what, this doesn't help me that much. Oh, that's what they're doing. That's so much easier. Okay, watch. This is what they do. This is what they do. Now I get it. Because I never really had a method for these. I just sort of figured them out. But, okay. So it's like they cut the first one up into this. They cut the second one. Wait, I think this is what they did. Hold on. Is that right? Got it. No, they didn't do that. They did x squared. Well, why do they rewrite it that way as x minus? Oh, I get it. I get it. They're trying to factor by grouping. Okay. I see what they're doing. So let me just try and understand it really quick. Now I'm going to come to questions, so don't go anywhere. I'm going to be there in 1 minute. So we have x squared. So what they did is they tried to make this a 3x by subtracting x. Let me probably have to add an x or something. And then to balance that out, and then they grouped this as minus 3, and they broke that off. Then they factored x minus 3 and then minus 2. Yeah. So they're all doing it relative, and then they broke it up into these fractions, you see. And then they get this. So that's how you get x plus 1 minus 2. Okay, so now I have a better idea on how to approach those. Let's go to questions. All right, looks like no questions today. Again, if you guys are watching this after the fact, I'm really sorry that it has to be at this time. This is the only time where I can manage time-wise to come and knock these out. So if you're watching after the fact and you have questions or things don't make sense, please leave a question in the comment section. Also, feel free to reach out to me directly at huzeif@scalarlearning.com if you have additional questions. We'll definitely get back to you. And every question or comment, I always try to respond to within a day, so make sure to post something, and I'll be happy to write you back. If you are taking the SAT this Saturday, keep prepping. Tune in with me tomorrow. Tomorrow's going to have to be earlier because I gotta start tutoring at almost 1 o'clock. So we're going to probably have to start around 11 or 11:30 to do an entire calculator section. But tune back in for that. And then, of course, Friday, we're going to have a big one. We're going to knock out the entire test 8. And, yeah, that's it. So hope this was helpful. Click that like button if you liked it. And make sure to subscribe if you want to see more. That's it for today. And I will see you guys next time. Take it easy.